Welcome to today's class. Today's class is set part 4. Set part 4 is actually the continuation of set part 3. Set part 4 is actually the continuation of set part 3. So, in set part 4, we have one, two, three examples. Three examples that we want to look at. The first one is given that P is equal to the set of A, B, C, D. Find the number of subsets in P. Find the number of subsets in P. The number of subsets in P is simply uh, the number of power sets. Remember, we said power set is the set of all the subsets of a particular set. Power set is the set of all the subsets of a particular set. So, if you are asked to find the number of subsets here, the formula for that is 2 raised to power n. 2 raised to power n. So that means that the number of find the number of subsets there, the number of subsets of that set, the set is P, will be equal to the number of subsets of the set P will be equal to 2 raised to power n. And what is n? N refers to the number of elements in that set. In other words, the cardinality of that set. And so that will give us 2 raised to the power of 2 raised to the power of 4, which is 16. And so that is option D. That is option D. 2 raised to the power of 4, which is 16. So that's option D. Now we look at question number 5. P and Q are two subsets such that n of P, that is the cardinality of P, is 17. N of Q, that's the cardinality of Q, is 14. And n of P intersection Q, that's the cardinality of their intersection, is 5. Find n of P union Q, that's the cardinality of the union set. This is question number 4, which is actually a continuation of set part 3. So question number 5, the cardinality of P union Q is simply equal to the cardinality of P plus the cardinality of Q minus the cardinality of P intersection Q. And so the cardinality of P is 17 plus the cardinality of Q is 14 minus the cardinality of their intersection, that is minus 5. And so this gives us 31 minus 5. And that gives us, was it an objective question? It wasn't an objective question. So that gives us 26. 26. So 26 is the answer to question number 5. Now we look at question number 6. Question number 6. Question number 6. Let me solve it here. Question number 6. P and Q are subsets of the universal set defined as the universal set is equal to the set of x such that x is an integer. What is an integer? An integer is a whole number. And 1 is less than x is less than 15. If 1 is less than x, it means x is greater than 1. So what we have here is 1 is less than x and x is less than 15. P is a set of x such that x is an odd number. And Q is a set of x such that x is a prime number. Then we have to find the cardinality of P prime, the P complement intersection Q complement. First of all, what is the universal set? X or 1 is less than x, that means x is greater than 1. So from 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15 is not included because of this less than 15. So 15 is not included. All right. And then P. X is P is a set of x such that x is an odd number. Remember, The universal set is a background set upon which elements of all other sets can be derived from, which means elements of set P and set Q are gotten from the universal set. So if X is an odd number, it will start from 3 because 1 is not in the universal set, so you cannot include 1 in the set of P. All the elements in the set of P are gotten from the universal set. So the first odd number in the universal set is 3. So we have 3, 5, 7, 9, 11, 18, that's all. And so Q is a set of X such that X is a prime number. Prime number. The first prime number that we have there is 2. We have 3. We have 5. We have 7. We have 11. And we have 18. Those are the prime numbers in the universal set. Remember, all the elements in P and Q are gotten from the universal set. So we are asked to find the cardinality of P complement intersection Q complement. So what is P complement? P complement simply refers to all the elements that are in the universal set but not in the set P. All the elements that are in the universal set but not in the set P. So we have 2. We have 4. We have 6. We have 8. We have 10. We have 12. We have 14. And then Q complement simply refers to all the elements that are in the universal set and not in the set Q. All the elements that are in the universal set and not in the set Q. We have 4. We have 6. We have 8. We have 9. We have 10. We have 12. And we have 14. And we have 14. Now, we were asked to find the number of subset or the cardinality of their intersection. So P complement intersection Q complement. Intersection refers to all the elements that the two of them have in common. All the elements that the two of them have in common. They have 4 in common. They have 6 in common. They have 8 in common. They have 10 in common. They have 12 and 14 in. They have 12 and 14 in common. So the cardinality of that, cardinality simply refers to the number of elements in that set. So how many elements do we have here? 1, 2, 3, 4, 5, 6. So the cardinality is 6. That gives us option D. Option D is the answer to that question. Okay, so with that, we have come to the end of set part 4. We have come to the end of set part 4. If you are coming across my video for the first time, do well to click the subscription button. So bye for now.